Hi, my name is Nayanar. I am from the company Design Science. Our mission is to make our customers successful by reducing the cost and complexity of engineering. To that extent, in the next 15 minutes, I am going to demonstrate our product DSTools, which will take the complexity away of complexity of a job of a tool designer away. Now, this is a typical cycle a tool designer goes through. On receiving the component to be manufactured, the first thing that he does is to unfold the component, followed by nesting, which will lay out the unfolded part in a way to reduce wastage, followed by a strip layout wherein you decide which station to do what operations. Now, this normally is followed by punch design for each stations, and from then on the designer shifts to die set design. From the die set design it goes to the drawing generation. The die set is one of the critical components in the entire operation, because it is it holds all the pieces together, the punches, the die, the strip, everything together, and handles huge amount of forces. From the die set, finally the drawings are generated and a bill of material, which gives information about what part, what material, what needs to be procured from outside, and like that. Now, in this unfolding, nesting, strip layout and punch design is handled very well by our partner product 3D Quick Press. Our product DSTools focuses on die set design and drawing generation. In this entire process, there are two types of complexities that a tool designer faces. The first complexity that a tool designer faces is the die set design requires a very good understanding of the different very good understanding of the tool design as such. It's primarily about deciding whether to have a single die set or a double die set or a triple die set, how many guide pillars are required, what kind of force is required. Like for example, if the length of the die set becomes large, then the bending forces become very high. So at that point you have to choose to split the die set into two. So these are choices that a die set designer makes to make sure that the die set can withstand the kind of forces as well as within the accuracy that is expected. This is one type of complexity that a tool designer faces. The other part is that the entire product is based on SolidWorks. So this die set can contain easily around 100 plus parts. So the tool designer has to be an expert in SolidWorks to be able to assemble all these pieces together and then make a usable, well designed die set. So with DSTools, we take away both this complexity by providing choices to the user, easy choices to the user, as well as making use of the choices to generate the die sets and make decisions on the standard parts as well as the required die set sizes. And from this designed die set, the bill of material as well as the drawings are generated automatically. Now with this, let me go to the demo. This is a laid out strip that is generated from 3D Quick Press. Now to manufacture this strip, the tool designer has to decide what kind of die set to be used as well as the materials and other paraphernalia. Now inside this you see this pull down menu, which is the plugin developed by Design Sense. It has a die set design as well as a die set bomb. Now to manufacture this, let me start by initiating die set design. When you invoke this, you see that there is a strip width and the length. This is picked up from the strip that is open already. For this, you see a certain set of designs that are recommended for manufacturing this particular die set. since the length is more than 300, which is around 660, DSTools is recommending a double die set, and you can choose what should be the punch height, and then it also tells you what kind of force is this die set can withstand. If you change your width and length, you will see different set of designs. We will go through that motion a little later. Now let me see, okay, what happens when I pick one of these designs. Now it is generating the required die set parts one by one. So it is putting together piece by building this die set piece by piece, making choices for each of the parts that are to be assembled together. Now that we have created the die set, let's look at the entire assembly. It has got more than 120 components. Let me see an exploded view of this assembly, and then see. You can see the entire assembly being exploded. You can see the guide pillar, the die plates, the bottom and the top plates, the springs. You can see all of them, that you can get a feel of the number of components that are part of this particular assembly. Now that I have seen the die set having come to life, let me do a quick sanity checks. Let me see if there is any interference because of all these components having been generated. Now I see that there is no interference, which means that the part will assemble appropriately. Now that we have come up to this point, let me show you our die set bomb. The choice of the materials is decided based on what is the production rate, what kind of operation that we are looking at, and what is the raw material that is being used. Now I'm choosing a very high production rate, which is more than 5,000 components. That is the general standard being followed, and the raw material that is being used for manufacturing this particular part is brass. So we are choosing the materials and attaching the right materials to the different parts. Now let me go ahead and create a bill of material. You see that design says bill of material template. Now this template will let you decide, is predefined for tool designer, so that it generates the right kind of information. If you look at it, it has all the information that is required for the manufacturing person to look at. What is what kind of harness is required, and what is the size of the different plates, what is the material that is being used for that particular part. When I create a drawing, let me create a bill of material in the drawing view. Before that, let me do the balloons. Insert. Let me do the auto ballooning so that we know what parts we are talking about. So I'm creating a bill of material for this particular die set in the drawing. So you can see that there's a description, a material, as well as hardness, which are all required for the manufacturing guy to look at and then and manufacture that particular part appropriately. Now this die set has got more than 120 parts. Now it also tells you, the bill of material also contains information about what is the whether it is a standard part or a non-standard part, like guide pillar or the bolts or ball cage, or generally ordered from outside or from a any specific standard. So by looking at the bill of material, the designer will know what is standard part and what is non-standard that needs to be manufactured. Now because of this automation, the process, which normally will take anywhere between 3 to 4 days for creating this die set and the assembly accurately, and the bill of material, can be done in a few minutes of the time. And also the tool designer, and this can be done in by making a very few choices. I was showing you the double die set, so let me also show you this length. Strip width and length can be edited without reading from the strip. So let me put some numbers here, and let's see what comes up. So for a strip length of 30 by 200, I am given two choices of the die sets. Let me pick this and then see what is coming up. Yeah, so what we have got now is a single die set, but since the size is small, it doesn't need those extra guide pillars. So these kind of choices are made following the production standards, thereby making the job a lot easier for the end user. This way, the user is given a choice of the die sets which meets his or her requirement, thereby reducing the amount of time and the complexity of the entire tool design process. A tool designer can focus on the component specific part, like nesting, strip layout and things like that, and leave the die set design to our product DSTools. A die set which takes anything like 3 to 4 days to generate the complete drawing and the bill of materials can be done in a few minutes of time. That is the benefit that DSTools gives to a tool designer. With that, we complete the demonstration. Should you have any queries, do get back to us at info@thedesignscience.com. Thank you.